The door I just came through serves one main purpose. It forms a barrier between the inside and the outside of the office. Keeps the bugs outside, and depending on the season, it keeps the warm or cool air on the inside. In any case, the door is serving to hold something in or keep something out. That same principle can be applied to your daily work routine when it comes to safely isolating energy sources.
This is the first section of a 3-section module on blinding. In this section, you'll learn about the functions of blinds, different types of blinds, and operating conditions that require blinding. Plus, you'll see some oil field equipment that is sometimes mistaken as a blind.
Maintenance, repairs, and new installations of equipment are a way of life here in the oil patch. Now, often, in order to perform any of these operations, you have to effectively isolate energy sources or hazardous fluids using one of 3 main methods. This module specifically addresses blinding, although disconnecting equipment and piping or a double block and bleed are used in some cases.
Blinding means stopping a process flow by placing a properly rated obstruction in the line. It's the preferred method of isolation. By stopping the process flow, the blind prevents the release of combustible and toxic materials, vapors, or gases into the work area. This ensures the vessel or equipment will remain safe and not become contaminated. The blind, sometimes referred to as a blank, must be made of the proper material in order to withstand the maximum temperatures, pressures, and corrosive effects often found in liquids and gases. It is therefore extremely important to use the proper type and size of blind for the specific application.
Let's talk a bit now about conditions that require blinding. Some of the most common situations include confined space entry, welding, commissioning or startup of equipment, maintenance, repairs, and extended equipment shutdown. Let's briefly examine each of these situations.
Vessel and confined space entry standards have been established by OSHA. These standards require that blinds be installed in all appropriate locations whenever personnel prepare to enter a vessel or confined space. Appropriate locations can be defined as the closest point to the confined space in all lines and fittings that open into that space. This properly isolates operating equipment and protects people from any subsequent unexpected release of energy or hazardous fluid. Welding or burning on process piping or vessels normally requires that the equipment or process be isolated from the welding area. All connected process lines, fittings, and vessels should have a blind installed at the closest point to the welding site. Starting equipment often requires flushing, purging, and pressure testing of vessels, lines, and other operating equipment. During these activities, blinds are often necessary to ensure that affected areas are properly isolated. Maintenance and repair activities that require opening or disassembling of machinery, piping, or vessels dictate that blinds be installed at all appropriate locations. Extended shutdowns of operating equipment usually require that blind flanges be installed on openings to the atmosphere in order to protect personnel and the equipment. In addition, blind flanges are frequently attached to seal openings on equipment which will be connected later, and blind flanges may also be used to seal pumps, compressors, vessels, and operating equipment that are being prepared for storage.
In order to select the proper type of blind, you must be able to recognize different types of flanges, since each different type of flange requires a compatible blind and usually a compatible gasket. Using an incorrect blind could result in blind failure, potentially injuring you or a fellow worker. There are 3 common types of flanges: the raised face, the flat face, and the ring-type joint.
The raised face flange has a gasket mating surface that extends above the remaining surface of the flange. The flat face flange has a gasket mating surface that is flush with the remaining surface of the flange. And the ring-type joint is a flange whose mating surface has a groove that mates with a corresponding groove in the adjoining flange. A metal ring is inserted into the groove and then deformed to fill the grooves as the flange is tightened.
Blinds are designed to fit specific types of flanges, so in order to select the proper blind, you should know and recognize the various types. Picking the incorrect type or size of blind could result in blind failure. Common types include the slip blind, the spectacle blind, the ring-type joint blind, and the blind flange.
The slip blind is a solid circular metal plate constructed with a T-handle that should extend 2 inches above the flange. Slip blinds are inserted between gasketed flanges to prevent the flow of gas or liquid in either direction. A spectacle blind is a combination blind and spacer shaped like a figure 8. The function of the spectacle blind is indicated by its position. If the solid portion is visible, the device is working as a spacer, permitting flow to occur. If the open side is visible, flow is blocked, and the device is serving as a blind.
Spectacle blinds are part of the equipment and remain in the line. They provide proper spacing between flanges during design and operating phases of the project. It also means the proper size and type of blind is already on hand when a blinding situation occurs.
Blinds for ring-type joints are made specially with a groove that matches the groove in the flanges. The fourth common type is the blind flange, which is a pipe fitting used to cap the flanged end of an open pipe or valve. Normally, the blind flange does not have a handle, and it is the only type of blind that has holes for bolting it to another flange.
There are also some devices on the job that can easily be mistaken for being blinds. Inexperienced workers can see this equipment in place and incorrectly assume that a blind has been installed.
Generally, equipment with a bar or tab handle is not a blind. Things like spacers, wafer check valves, screens, and orifice plates fall into this category. Remember, blinds should have a T-handle or no handle at all. A spacer is a metal disc similar in appearance to a blind, except the spacer is not solid and allows flow through the disc. Spacers and slip blinds appear almost identical when installed in a line. Spacers are typically set in locations that require frequent blinding. They reduce the need for spreaders or other heavy tools to spread the flanges for blind installation. The worker removes the spacer and replaces it with the properly rated blind. A screen is a device normally installed upstream of a pump or compressor suction. It is designed to keep foreign material out of the suction and usually has a bar handle. The orifice plate is a device used for flow measurement, pulsation control, or creating a side stream by pressure drop. It's a metal disc normally much thinner than a blind or spacer. When inserted, the orifice plate can be identified by its relatively thin construction and its bar or tab handle. Orifice plates used for flow measurement can be identified by the pressure taps connected to either side of the flange.
That brings us to the end of Section 1. Please stop the videotape and review this section in your manual, filling in the blanks as you go and answering the questions at the end of the section. When you're finished, restart the tape and we'll move on to Section 2, blinding preparation. As we mentioned in the last section, blinding is not a one-size-fits-all operation. It's vital that you select the right type and size of blind for your application, and that means using your head.
This is the second section of a 3-section module on blinding. In this section, you'll learn how to select or construct a proper blind. Plus, you'll see the tools and the equipment normally used for properly installing a blind.
Selection standards are most important if blinds are to be effective and safe. Carefully following blind selection guidelines can help you determine where blinds should be installed and the type of blind that can do the best job.
The correct blind should match the size and pressure rating of the line or equipment and the type of flange on which the blind will be installed. When gaskets are used with blinds, they should also be properly rated for the pressure and size of the flange. The surface of the blind should be smooth and fit snugly against the gasket next to the face of the flange or valve. There should be no visible cuts, crimps, or gouges on the face of the blind. All blinds except blind flanges must fit inside the bolt pattern of the flange or valve. Remember that spectacle and slit blinds will be smaller than the flange.
Blinds from approved manufacturers will be designed specifically for the size, type, and rating of the particular flanges. Usually, our company will have a standing blanket order with approved manufacturers. Buying blinds from these vendors helps assure correct thickness, flatness, and smoothness of the blind surface, but you should still always make a visual inspection to ensure that the quality of materials is correct.
Blinds for ring-type joints should always be purchased from an approved manufacturer who has designed the blind specifically for the size and rating of the flanges involved. Never, ever use a ring-type joint blind that has been manufactured in the field.
Gaskets, except with ring-type joints, are components of blind installations, and as such, they're subject to the same failures as blinds. So gasket selection is as important as blind selection in maintaining the integrity of the blind. Gaskets should never be recycled. Always use a new gasket when blinding.
The gasket should have the same pressure and temperature rating as the flange in which it will be inserted. Normally, a gasket should be replaced with a type identical to the gasket that was removed. Make a visual inspection of the gasket to be certain it is flat, smooth, and has no crimps or defects. Also, make sure the flange face is clean and smooth before installing the gasket. The gasket, like the blind, must fit inside the bolt pattern of the flange. The gasket should be snug against the face of the flange.
Along with proper sizing, blinds must be rated to hold or withstand a specified amount of pressure. The pressure rating for the blind should be the same as the ANSI pressure rating for the flanges into which the blind will be installed. ANSI, by the way, stands for American National Standards Institute. Okay? Now, the ANSI class rating is normally stamped on the edge of the flange. If it cannot be read, the reading may be determined by contacting your facility engineer, or in some instances, by following the procedure outlined in your student manual. In any case, should you ever have a question about choosing between two ANSI class ratings, pick the higher class. In other words, when in doubt about a flange class, use the stronger blind.
And don't try to make a blind in the field unless it is absolutely necessary. Suitable blinds should be purchased prior to starting a job. Should an emergency require you to make a blind in the field, use the criteria listed in Appendix A of your student manual to determine the minimum thickness required for the blind.
Never construct a blind in the field to service ANSI Class 600 or greater. Blinds for ANSI Class 600 or greater must be constructed of alloyed material not normally found at work sites, so be sure to obtain those blinds from an approved manufacturer.
Blinds that must be made in the field should have a T-handle that extends 2 inches beyond the edge of the flange. The T-handle should also have a hole for attaching a tag and a flag. Field fabricated blinds should also be stamped with a correct ANSI class or pressure rating. Pressure ratings for blinds can be checked by looking at the ANSI class and maximum allowable working pressure for the particular temperature. Appendices C, D, and E in your student manual contain this information. Let's take a look now at the best places to install blinds. Pick a location that is both accessible and as close as possible to the equipment being isolated. When assessing possible blind locations, consider alternate sites that serve the same isolating function. All things being equal, the preferred blind location would be that which offers the best combination of the following factors. First, the location provides the safest, easiest access, near ground level, for instance. That way, no scaffolding or ladders are required. Second, the location closest to the isolated equipment is ideal because it avoids long runs of piping that must be purged of gas or trapped liquid. And finally, the location should give you the ability to bleed trapped pressure before the blind is removed.
So far in our isolation process, we've selected the correct blinds and determined their locations. Next, be sure you have all the proper tools and equipment, including the following: scaffolding for reaching the blind location or to avoid climbing on equipment, hand tools, wrenches, impact wrenches, torque wrenches, and torque multipliers or drift pins, spreaders to part the flanges for inserting a new blind, or to hold the flanges open while a spectacle blind is reversed, bolts or studs long enough to provide exposure of one full thread after the blind has been installed. Other supplies, such as scrapers to remove old gaskets, new, properly rated gaskets, tags, a blind list, and flagging tape. Of course, appropriate personal protective equipment should be worn at all times. Be sure to use the specific safety clothing and equipment that apply to the situation in which you are working. Hazardous materials and extremely hot or cold temperatures are just some of the conditions that will dictate what you use. And that brings us to the end of Section 2. Please stop the tape at this point and read over the material in this section of your student manual, filling in the blanks as you go and answering the questions. And when you've finished, restart the tape and we'll be back with Section 3, blind installation and removal. Preparing for blind removal and installation is in most cases very simple. It just requires planning and coordination along with the proper tools and equipment.
This is the third section of a three-section module on blinding. In this section, we will cover blind installation and removal. In order to correctly install a blind, you should understand the following: the importance of job planning, the importance of developing and using a complete blind list, site preparation requirements, blind installation procedures, tagging and flagging requirements, and blind removal steps. For more details on these elements, refer to your student manual. Appendix G of your student manual contains a sample blind list. Completing a blind list like this during the planning phase will help guide you in obtaining the properly rated blinds from manufacturers. The blind entry list should include the blind number, a description of the blind location, the date of installation or removal, and the name of the person installing or removing the blind. Site preparation involves making sure the required equipment and tools are on hand, as well as the following: that all parties working on the system have reviewed the work site. A fire and safe work permit is recommended for specialized or hazardous work areas. All lines, valves, and vessels should be depressurized to atmospheric pressure and drained. The same lines, valves, and vessels should be flushed and purged according to purging procedures. Equipment should be isolated according to proper lockout-tagout procedures. Safety equipment should be available and ready. After all the previous steps have been completed, the flange or valve can be unbolted. The flange is then separated and spread. After the flange is separated, remove the old gasket. The surfaces of the flange and blind should be cleaned and prepared for installing a new gasket. The gasket is then applied to the flange and the blind installed. In the case of a spectacle blind, the existing blind can be removed, inverted, and reinstalled using new gaskets. When installing a ring-type joint blind, the groove in the blind should match the groove in the flange on the side that may contain pressure, temperature, fluids, etc. Remember to use a new ring when installing the blind. In order to achieve the design pressure rating for the blind, you must install all the bolts of the proper length in the bolt pattern of the flange, and tighten all the bolts and nuts with a torque wrench to the level required for the respective ANSI class rating. Be sure to tighten the bolts in a star pattern. If you don't do it this way, the blind may not hold the designed pressure rating. After the blind is secured, the blind and flange area should be gradually stepped up in pressure and tested with a detector for any leaks. If leaks cannot be stopped, depressure, purge and flush again, then disassemble the flange and check the components for imperfections. After installation, tag the blind so it can be easily located for removal. The tag should contain the name of the person who placed it, the date, and reason for blinding. Flags can be used to identify blinds that are hard to see. Flags are recommended for all blinds as a safety precaution. Never install a flag without a tag. Tags should be attached either in the hole drilled in the T-handle or through the open end of a spectacle blind. After each blind is installed, record details on the blind list and tag it with a number corresponding to that list. Removing a blind is essentially the same procedure in reverse. If conditions required a safe work permit, be sure it remains in effect or that a new fire and safe work permit is issued. See that a purge procedure has been prepared for returning the equipment to service. Purging might require the last blind be used as a vent location. Follow appropriate lockout-tagout procedures to ensure that equipment is properly isolated. Again, be sure safety equipment is available and ready. At this point, the flange can be carefully unbolted. Remember, there may be pressure on the line from leaking valves. The flange can now be separated, spread, and the blind removed. Now remove the gasket. Then clean and prepare the surfaces of the flange and install a new gasket. If you're dealing with a spectacle blind, invert the blind between the flanges. With ring-type joints, remove the ring while the flange is separated and make sure the surfaces of the flanges are clean. Put in a new ring and secure the flanges with the correct length bolts or studs. The flange or valve should be secured with properly sized bolts and nuts in all bolt holes. Tighten the bolts to the torque specified for the ANSI class rating of the flange or valve. After removing the blind, date and sign the correct number on the blind list to indicate the blind has been removed. Before putting the equipment in service, make sure that all flanges are secure. Lines should then be stepped up in pressure to check for leaks. If a leak does occur, the system can be depressured more quickly than if full pressure were applied. If you can't stop the leak by properly torquing the flange, Then disassemble the flange and check all the components for imperfections.
Although blinding is the preferred method of isolation, it's not always possible to install a blind. In those cases, disconnecting the piping or using a double block and bleed may be required.
Disconnecting a line and maintaining the break will ensure isolation. In these cases, proper tagging and flagging of line components is required. The double block and bleed is a process whereby two valves are closed with an open vent or bleed valve between them. This is the least desired of all isolation techniques. Double block and bleed should not be used unless it is physically impossible to blind or disconnect the line. It is recommended to lock the block valves closed and the bleed valve open. In some cases, you can remove the valve handles in lieu of using locks. The bleed valve must also remain open to the atmosphere. The bleed valve must be sized so the full capacity or flow from the current operating conditions can be relieved.
That concludes this module on blinding. Stop the tape now and review your student manual, filling in the blanks in section 3 as you read, and then answering the questions at the end of the section. And remember, proper blinding is the preferred method for isolating energy sources, and it's one more way you can help prevent accidents. I'll see you next time. Mm. Mm. Mm.